Today we are going to learn about covalent naming. Our question of the day is what are a few ways you can distinguish between ionic and covalent bonds? Now, remember a covalent compound is one where a nonmetal is bonded to another nonmetal by sharing the electrons. Some examples are NH3, CO2, and H2O. So in order to name these molecular compounds, you only need to count the atoms and use prefixes to indicate the number. Yes, it really is that easy, and I will show you some examples. Just like when we were looking at ionic compounds, the second element will have its name changed so that it ends in "ide." This will tell you that the element has been bonded and is not just sitting there as a single element. There are a few little problems you might want to look out for. First of all, if you only have one of the first atom, such as CO2 for instance, you do not use the prefix mono. So you do not use the prefix mono for one if you only have one of the first atom. Here is an example. CO2 is called carbon dioxide. There is only one carbon, so we do not need a prefix in the beginning. However, dioxide to oxygen, that does have a prefix. Number 2, if the name of the element plus the prefix mono gives you a double vowel, so A-E-I-O-U, we're not counting Y, eliminate the vowel from the prefix. So, take a look at CO2 for instance. We said monoxide, not monoxide. So, how do you know what prefix to use for each number of atoms? Well, mono means 1, di means 2, tri means 3, tetra is 4, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So, if you can get 1 through 4 right, from 5 on, it's just the same prefixes you would use in math. So, like a pentagram has 5 sides, or an octagram has 8 sides. So, now let's look back at those initial examples I gave you. NH3, the first element is nitrogen. There's only one, so we don't need a prefix. And for the second element, it's hydrogen, so we'll change the ending to "ide" and add a tri at the beginning for 3. Nitrogen trihydride. CO2, once again, is carbon dioxide, 1 carbon, 2 oxygens. Now, another name for H2O, besides water, is dihydrogen monoxide. Di meaning 2, hydrogen is self-explanatory, mono for 1, and oxide for oxygen. Now, once again, notice how we use the prefix mono if we are on the second element but not on the first. Now, pause the video and try the show what you know problems. So, practice time. BrCl5. Br is bromine. There is only one of them, but we do not put mono on the first one. Cl is chlorine, which we need to change to chloride. 5 means we're going to use a prefix of penta, and we have bromine pentachloride. Now, what about SO3? S is sulfur. There's only one. We don't need a prefix. O is oxygen, which we change to oxide, and we use the prefix tri for 3, so sulfur trioxide. For number 3, we have P2O3, so we have 2 phosphorus or diphosphorus, and then we have 3 oxygens or trioxide. Now, look at number 4, As3P5. So As is arsenic, there are 3 of them, so we use tri. P is phosphorus, which makes it a phosphide when it's bonded, and there are 5 of them, so it's penta, triarsenic pentaphosphide. Let's look at number 5. We have IF7. I for iodine, F for fluorine, or fluoride in this case, and we don't use a prefix on the I because there's one. However, we do need a prefix for the 7 fluorines, and that would be hepta, so it's iodine heptafluoride. Let's look at number 6. We've got sulfur starting off strong. There's no prefix because it's only one. And for the second element, we have Br, or bromine, which there are 6 of. So that becomes hexabromide. So sulfur hexabromide is number 6. Look at number 7. We have N2O5. That's 2 nitrogens, or dinitrogen, and 5 oxygens, which we change to pentoxide. So now we look at number 8. That's PCl3. P is phosphorus. Once again, no prefix needed. Cl is chlorine, or in this case, chloride, and 3 can be written as tri, so phosphorus trichloride. Once again, we only have a single of our first element, carbon, so there is no prefix. Then Cl is chlorine, and there's 4 of them, so our ending's going to be tetrachloride. Now let's look at number 10, PBr3. P is phosphorus, no prefix necessary, and there are 3 bromines, so tribromide. Now let's see if we can go backwards. This should be easy. Dihydrogen is H2, monoxide is just 1 oxygen, H2O. Sulfur is S. Dioxide means 2 oxygens, or O2, so SO2. Now we're looking at dibromine, so Br2, and monoxide, so just 1 O. And we are left with Br2O. Let's look at 14, diphosphorus pentoxide, di meaning 2, phosphorus, and pent is 5, oxide is oxygen. So P2O5. Now we look at 15. We've got carbon, no prefix, so there's just 1, and we've got tetrahydride, or 4 hydrogens, so CH4. Number 16 is sulfur hexachloride. Sulfur is S. Hexachloride means 6 chlorines, so SCl6. Now we look at 17, dinitrogen trioxide. Dinitrogen, 2 nitrogens, trioxide, 3 oxygens, N2O3. Number 18 is carbon disulfide. No prefix means it's just C, and disulfide means 2 sulfurs, or S2. So our final answer is CS2. Now, oxygen, no prefix, we're just going to write an O. Difluoride is 2 fluorines, or F2. So our answer is OF2. Now we want carbon tetrabromide. Carbon, no prefix, is just a C. Tetrabromide is 4 bromines, or Br4. So the compound is CBr4.